Alright, y'all, welcome to the DCA04 review. This is covering everything exponents, polynomials, and then also solving equations and inequalities. So let's jump in. Number one says, how do we multiply polynomials? The method that we have talked about and we all looked at on College Bridge is distributing. So you want to distribute everything from your first polynomial into everything in the second polynomial. And so what I'm going to do here is I'm going to take the x squared and I'm going to distribute it into everything here first. Then I'll distribute the 5x. Then I will distribute the 2. So starting with x squared, I'm distributing it into everything over here. Okay? All four of these terms. So x squared times 3x cubed is going to be 3x to the 5th because I add my exponents. X squared times x squared is going to be x to the 4th. X squared times negative 3x is going to be minus 3x cubed. And then x squared times 1 is just x squared. Switch colors for 5x. So 5x, again, I'm going to distribute him into all four of my terms over here. So 5x times 3x cubed is going to be 15x to the 4th. 5x times x squared is going to be 5x cubed. 5x times negative 3x is going to be negative 15x squared. And then 5x times 1 is just 5x. And then lastly, I'm going to distribute the 2. So again, the 2 goes into all four terms. So 2 times 3x cubed is going to be 6x cubed. 2 times x squared is going to be 2x squared. 2 times negative 3x is going to be negative 6x. And then 2 times 1 is just 2. So now that I have multiplied everything out, I am going to combine. So we distribute and then combine. Okay. So starting with my largest exponent, so 3x to the 5th. I have nothing to combine him with, so he just drops down. So we're going to be 3x to the 5th. Then I'm going to combine my x to the 4th, so I'm going to say x to the 4th and 15x to the 4th. X to the 4th plus 15x to the 4th is 16x to the 4th. And then our x cubed, so negative 3x cubed, 5x cubed, 6x cubed. Combine all three of those. Negative 3 plus 5 is 2, so plus 6 is going to be 8x cubed. Okay? Next are x squared. So I have an x squared here. I have a negative 15x squared and then a 2x squared. So I'm going to 1 plus 2 is 3 minus 15 will be minus 12x squared. Then my x's, I have a 5x and a negative 6x. That'll just be minus x. And then the plus 2 has nothing to combine with, so he drops down. Now this one is a longer polynomial, but don't let that scare you. The one on the DCA is not going to be as long as this. Number 2, it wants us to add and subtract the following. So I'm going to do the addition over here, and we'll do subtraction over here on the right side. So 2x cubed plus 5x squared minus 3x plus 2. And we're adding x cubed plus 5x squared plus 4x minus 4. So in this, since we're adding, just like we did before, we're going to combine like terms. So 2x cubed plus x cubed is 3x cubed. 5x squared and 5x squared combines to be 10x squared. Negative 3x plus 4x is going to be plus x. And then 2 minus 4 is minus 2. So this is my sum. Again, sum is for addition. Then over here, we're going to do subtraction. So 2x cubed plus 5x squared minus 3x plus 2 minus the x cubed plus 5x squared plus 4x minus 4. So this time, since we're subtracting, we want to distribute this negative sign, okay? So once we distribute the negative, then we can combine like terms like we did on addition. So this is going to become, this is going to become minus x cubed. So minus x cubed minus 5x squared minus 4x, and then it's going to become plus 4 because a negative times a negative is positive. So 2x cubed minus x cubed is going to get us x cubed. 5x squared minus 5x squared simply cancels out. Negative 3x and negative 4x combine to be negative 7x, and then 2 plus 4 is 6. Number 3 is a tricky one. It's not something that we have talked about too much in class, but there is a question about it on the DCA. So basically, what I want to do is we're going to call this polynomial A. All right, this left side is A. And we're going to call this right side B, just so I don't have to say the whole thing 15 times. In order to make it true, we need to make A equal to B. And so what I want to do is I need to figure out, for A, what do I need to add to make it equal to B? And so how that works is to figure out what this question mark is we are going to subtract A. Because then we'll have because this question mark, whatever we need to combine, is going to be B minus A. So you're going to have a question like this on the DCA tomorrow, so just know whichever side has the smaller first term. So we have a 3x cubed and a 2x cubed. This side is the side that is going to be your B. And then whatever side has the larger one is going to be your A. So you are going to end up with a negative first term. And I know this is strange. It's something we've done before. It's just a different wording than what we're used to. So what I'm going to do is I'm going to take the 2x cubed minus x squared plus 5x minus 1. And I'm going to subtract everything from A. So we're going to subtract 3x cubed plus 7x plus 2. And this is just like the last problem. We're going to distribute that negative. And we're going to have minus 3x cubed minus 7x minus 2. And then I'm just going to combine my like terms and figure out what would make this statement true. So what is missing on that left side to make it equal to the right side. So 2x cubed minus 3x cubed is going to be negative x cubed. Negative x squared has nothing to combine with, so we're going to say minus x squared. 5x minus 7x is going to be minus 2x. And then negative 1 and negative 2 is going to be minus 3. So this right here, if I were to combine it, again, with this left side, it would make it a true statement and make it equal to my right side. So again, this is just a weird way of asking a subtraction problem. We've done it before, so don't let the wording scare you. Number 4, what is the solution to the equation? This is just solving for x. We've done it a million times. So we're going to subtract 3. We're going to get 2x equals 4. Divide both sides by 2. We get x equals 2. Done. Great. Move on. Number 5 is just wanting us to write an expression. So again, we've done this a bunch. We just need to take the information it gives us, write an equation. So a group of friends are going to the movie theater and want to buy snacks before their movie. Bags of candy cost $2.49 each. Sodas cost $1.99 each. We want to write an expression that could determine their total cost. So we're trying to figure out, all right, how much money are they going to spend on candy and sodas? So what we're going to do is it's going to be $2.49 each. So it's going to be $2.49 times however many bags they buy. So we'll call that C. And then we're going to add how much they spend on sodas. So that's going to be $1.99 times however many sodas they buy, and we'll call that S. Since I have no other information, this is as far as my expression can go, and so this would be my answer. Number 6 is similar, but we're going to actually have to use it to solve something. So it says the cost to rent a boat at Eagle Mountain Lake is a $30 flat fee plus $15 per hour. If Brooklyn wants to rent a boat for her friends but only has $105, how many hours can she rent? So this equation, we know what it's equal to. We know it's equal to 105 because that's as much as we can spend. $30 flat fee, that's just $30, no ifs, ands, or buts. But then we need to add the cost per hour, and so that is going to be $15 times, we'll say X, however many hours we spend on the lake. So we need to figure out how many hours we'll use all of our 105. So we're going to subtract 30. And we're going to get 15x is equal to 75. Use your calculator at this point if you need to. Again, scientific calculator only. And then we're going to divide by 15. And so we get x is equal to 5. So she can rent it for 5 hours with the amount of money that she has. 7, solve the following equation. We've done this before, so keep in mind if you get the same number of x's, so same x, and same constant, so same number, you have infinite solutions. You have infinite solutions. If you get the same x but a different number, a different constant, like plus or minus something, that is no solutions. But again, the x's have to be the same. If you have a different number of x's, so if you have like a 3x and a 2x on either side, that is not either of these two, okay? So looking at this, I'm going to distribute the 5 in first, and I'm going to distribute the 3, because I needed to get rid of those parentheses before I can start trying to solve for x. So 5 times x is 5x, 5 times negative 3 is minus 15, and then that plus h drops down for now. And we are equal to 3 times 2x is 6x, 3 times negative 5 is minus 15. On this left side, I'm going to combine my x's real quick. So we're going to get 6x minus 15 equals 6x minus 15. So this is this rule right here, because we have the same number of x's and the same constant, the same number. We have minus 15. So that means I have infinite solutions. Okay? An example of no solutions would be if we had 6x minus 15 equals 6x minus 14. That is the same number of x's but a different number. That is no solutions. Because if we were to graph those would be parallel lines. Number 8, it says to solve the following inequality. So again, I basically need to solve this side, solve all of this stuff, and then we're going to try to get x by itself. So like we did last time, I'm going to distribute the 3 and the negative 2. So 3 times x is 3x, 3 times 1 is 3, negative 2 times x is minus 2x, negative 2 times negative 2 is plus 4, and it says we're less than or equal to 3. Combine my x's, 3x and negative 2x is x, 3 and 4 is 7, and that's less than or equal to 3. So we're going to subtract 7. We're going to get x is less than or equal to negative 4. Simple as that. We treat it the same as other inequalities. Just remember, if you divide by a negative number, so a negative number, actually we'll say negative and then number sign. A negative number, you have to flip the inequality. So this one didn't have a negative. I don't recall if the DCA has a negative, but just remember, if it is negative, you have to flip the inequality. Now the last one is division. I know we don't love division, but it's going to be okay. So one thing I am going, there's a couple different ways to solve this. All right, we didn't talk about synthetic division much in class, so I'm going to solve this long division. But if you know synthetic division, if you remember it from Algebra 2 or whatever, you are welcome to use that method as well. So I'm going to do x plus 3, and I'm dividing x cubed plus x squared minus 14x minus 27. So x times something gets me x cubed. X times x squared gets me x cubed. So I'm going to now multiply x squared times x is x cubed. X squared times 3 is 3x squared. And I'm going to subtract these, okay? So x cubes, those cancel. X times 3x squared is going to be negative 2x squared. And I'm going to bring down the minus 14x. So x, all right, we already know it's going to be negative 2. So x times negative 2x, to get negative 2x squared, we're going to multiply by negative 2x. So we'll get negative 2x squared. And then negative 2 times 3 is going to be minus 6x. So those cancel. Negative 14 minus negative 6 is going to be negative 8. Bring down the minus 27. X times negative 8 will get me negative 8x. Negative 8 times 3 is going to be negative 24. Subtract those. Those cancel. You're going to be left with negative 3. So your answer is x squared minus 2x minus 8 minus 3 over x plus 3. Remember that remainder. So that's going to conclude our DCA review. If you have any questions, let me know. Otherwise, study hard and good luck.